A warm welcome. This is Control Systems course, lecture 4.3, representing the effect of lag lead and lag lead compensation on frequency response. Let us start with the lag compensation. Actually, a lag compensator is an electrical network which produces a sinusoidal output having the phase lag when a sinusoidal input is applied. You can see the lag compensator circuit in the S domain, where the figure represents the Vi of S as input, R1, R2, and the capacitor is given, and we have V0 of S as the output. This is the equivalent circuit of an electrical lag compensator. The magnitude plot and phase plot can be drawn accordingly. We can find that in the magnitude plot, the curve is constant, and then later on it starts decreasing and reaching the zero value. While in the case of phase plot, you can see it is at a level, and after that it is decreasing. The phase value is decreasing, and then after that it is increasing. This is the effect of lag compensation on frequency response. While considering the lead network, the capacitor is connected in parallel with the R1. Actually, it is the lead compensator is an electrical network which produces sinusoidal output having phase lead when a sinusoidal input is applied. So here in this case, the capacitor is parallel to R1. And here, while looking at the pole zero plot, we can see that the zero is nearer to the origin when compared to the pole. The pole is away from the origin. So with this representation, we have V naught of S by Va of S, and later onwards we can have tau is equal to R1C, alpha is equal to R2 by R1 plus R2, and alpha is less than 1. Here the pole is 1 minus 1 by A tau, and the 0 is minus 1 by tau. On substituting S is equal to j omega, we can have the phase angle as such. And here we can see that initially the value is low, and after that the magnitude value is increasing. And similarly, the phase plot, by looking at the phase plot, it is low at the initial stage, and later onwards it is increasing, and then finally it is decreasing. This is what is the case of lead compensation. Next, while you are looking at the Bode plot representation, yes, while calculating the lead compensation, this one of the step is, first we have to find out the omega m value, the frequency value, which is 1 by tau into root of alpha. So we have to calculate alpha as well as the tau value. So in order to calculate the alpha value, let us consider sin phi m is equal to 1 minus alpha by 1 plus alpha. So alpha becomes 1 minus sin phi m by 1 plus sin phi m. On substituting this value, we'll find out the alpha value. And the modulus of the maximum phase lead is nothing but 1 by root of alpha. So that magnitude helps. Next is a lag lead compensation. So while considering the lag lead compensation, we'll have two capacitance, one parallel to the R1 and the other one series to the R2. So lag lead capacitor is an electrical network which has a phase lag at one frequency range and phase lead at the other frequency region. It's a combination of both the lag and the lead compensator. Let us so it's a combination of the lag part as well as the lead part. So everything will be the same here. First, the lag part is considered. So the pole will be nearer to the origin. Next, its corresponding or zero will be there. And after that, the zero of the lead compensation will be there. And then after that, the pole of the lead compensation part will be there. So this is how the pole zero plot